Welcome to Module 6. That's right, another module with me, the one and only, your instructor for the course. And in this module, number 6, we're going to be talking about two things. Number 1, we're going to talk about operations. And number 2, processes. Again, fancy terms that mean non-fancy things. That's all that this is. And you're going to find me relating this word of operations and processes to your everyday life, especially in the kitchen. So that's kind of where the science lab is at home. So a lot of this stuff that we can talk about there, of course, and you can relate to that because you've seen that in person firsthand. And I think it makes this information a little bit more easily digestible, of course, because it's in the kitchen. So we're going to start with section 6.1 and 6.2, and it's all about a general introduction. That's what this is. And what is an operation? What is a process? What are some of the terminology that we need to get comfortable with? That is what all of 6.1 and 6.2 is going to be about. So I first want to talk about a process. There we go, process. It's any activity that changes or physically changes matter or converts energy. That is a definition of a process. All right, so any activity that changes or physically changes matter, yeah, of course, that's what that means. So what does that mean, Tracy? All right, well, again, we have, let's say, cake batter. And I have made this cake batter in a bowl and I've mixed it. I've put my ingredients in it. It is ready. It is ready to go. All right. So I pour that cake batter into a pan. And when I pour it into a pan, I put it into the oven and ding, ding. After the time is over, I get a cake. And that cake is something that is totally different than what my starting products or my starting reagents are. So something has changed. Okay, now this is a physical change because I can see it, but it's also a chemical change, and that's because it is no longer anything like that cake batter that we had in the bowl in the very beginning. So some properties have changed here, and those properties are actually two different properties. We have physical properties, which means things that I can see, things that I can smell, things that I can feel, things that I can touch. And then we also have chemical properties that have changed as well. And these chemical properties are the nature of the substance. We know just by looking at this that cake is totally different than the cake batter that somewhat made it in the very beginning. So we get changes, and that's what this is all about. So a process, by definition, is how they're going to tell you this. A process is anything that we can do that changes this stuff, this matter, this stuff that we are working with, or converts energy in one form or fashion. That's what this is all about. So again, like I said before, we're going to relate a lot of things to the kitchen because I think that kind of helps you understand it a little bit better. Next, it says a process is a set of steps. Of course it is, right? There are steps of the recipes that I have to follow. There's steps that I have to do in the biomanufacturing realm that I have to follow. Those are going to be standard operating procedures. And these steps are going to produce something, and that something is going to be a product. So it says, for example, heating the cake in the oven, cooling, separating, mixing, growing, filling, purifying. All of these are processes that we are doing in the manufacturing line in order to make something. And that something is a product, and that product is then going to have to be cleaned up because guess what, folks? That is not really going to be purified in the very first step. So we want to take a few steps. We want to make sure that we produce a clean product, a safe product, an effective product, so that way we can release it to a consumer. So some terminology that's going to happen here, some of these common processes that we do, these are going to be called unit operations. Ooh, another term that made me sound really smart. So these unit operations are really going to be focused on two major categories. The first one is separation, and the second is purification. So separation is how can I separate the good stuff from the bad. I don't want the bad things, right? All of that is trash. I need to throw it away. I need to get rid of it. So, how do I get the good stuff from all the bad things that I don't want? That is the separation piece of what is going to be classified as a unit operation. And we're going to talk about some of these. And then second is purification. So now that I've got the good stuff, how can I make great stuff? That's what this is all about. So yes, I do have maybe a kind of good product here, but I know that it can be better, and I want to purify it, and I want it, to be the best that it can be before we send it out to a consumer. The same thing's going to happen to you in the kitchen, right? So all of us can make a cake, but the problem is that some of us can make better cakes than others. So how do they do that? What steps do they go through to make sure that that quality is the best that it can actually be? And that is the purpose of the purification operations, or the processes that we need to talk about in this particular lecture module. Some key trigger words here. Chromatography. What does that even mean? We'll definitely talk about that. Centrifugation. Ooh, that sounds fancy. So what's a centrifuge? Well, folks, that's like your washer at your house. So we'll talk about that as well. Filtration. All right. I know what a filter is. Is that what he's talking about? Well, sit back and enjoy the show, because you'll figure that out here in a second. And then distillation. What's distillation? I think that I've heard of that distillation stuff up in the mountains of North Carolina and Kentucky and Southwest Virginia. Isn't that distilleries? And the answer is yeah, kind of. So we need to talk about distillation as well. But at the same time, keep in mind that one or more methods can actually be used. So while we talk about these individually, that is great. Individual, that could work. That might be the only thing that's needed. Absolutely. We'll continue to go with the flow. But there is also a chance that we need to combo these as well. And when we combo them, well, that's not a big problem. It's just extra steps that we have to do. So what? I mean, we'll get there. We'll do it. I don't have a problem with that. It's just a little bit more time in the separation and the purification steps to make a really good product. And we want to make a good product. So that's what this is all about. So some common operations here. Yeah, there's kind of the few major ones that we talked about just now. But now let's kind of dive a little bit deeper into these different classifications. First off, we have cell culture and fermentation. So this is all about growth, okay? So we are growing things, and growing things is changing stuff, and changing stuff is processing and operations. And these are things that we need to kind of pay attention to. We need to focus on. We need to make sure that that process is actually happening the proper way. So cell culture and fermentation, we have kind of talked about before up to this moment. This is not anything new. And the operations that we're going to be talking about here is really going to be more of the, what I would call almost lab shadowing processes and operations. And you'll see what I mean when we get to our first batch. Next up is centrifugation. Centrifuge is just centrifugal force. And it separates mixtures. That's what this thing does. So I've often said, oh, well, centrifugation, think about your washing machine. Okay, so you're going to realize what I mean by that when we talk about centrifugation in a little bit more detail later on in the videos. But just another operation that we can mention now and say, hey, this is what's coming up. Be ready for it. So that way when we start talking about it, it's not kind of completely brand new for you. Number 3 is cell disruption. Well, when you disrupt something, you mess it up. And cell disruption here, you're messing up the cells. And by messing up the cells, that means that you are breaking them open. All right? So if I'm in the kitchen and I go to my refrigerator and I get a carton of eggs, well, cell disruption, that would be equivalent to me taking that egg and I am going to disrupt it. And I am going to crack it onto the edge of my bowl or the countertop, and I'm going to open the egg up, and now I have disrupted it, and I am released the Kraken. I'm releasing the egg on the inside. This is cell disruption, and there could be product in these cells, right? So here is my cell, and maybe there's a little bitty product right in here in the cell, and then I need to pop it open, and when I pop it open, all of the insides come out, and this is the product that I am after. I want this stuff. That's the good stuff. That's what we're trying to manufacture. That's what we're trying to make. That's what we're trying to bottle up. So cell disruption is going to be a part of the operations that, of course, that we're going to talk about and that we've talked about a little bit already. Number 4 is filtration. So filtration is all about filtering. That's what this is. So again, I'm going to go back to the kitchen, and I want to say, okay, I've got a huge pot, and in this huge pot, I've got some oil, and I have just deep fried some French fries. And I'm going to go old school, and I'm going to make my French fries from scratch. So I'm going to cut my potato up. I'm going to cut them into sticks. I'm going to soak them in water. I'm going to dry them off. And then I'm going to be fancy, and I'm going to put some batter on those French fries, like beer battered fries, and I'm going to dump them into the hot oil, and there it goes. It's frying. It's frying. In a couple of minutes, I'm going to have great French fries, better than what you can get into a restaurant. All right, good, great. So after the frying part, I'm going to remove the French fries, and the oil is going to probably have some sludge. It's going to have some batter that has fell off. It's going to have some skim in the bottom. It looks like burnt, charred little pieces. Okay, all of this I do not want to keep in there. I need to get rid of that, and filtration is going to allow me to do it. So I'm going to take maybe a filter paper and some type of funnel, and I'm going to pour that dirty oil into the funnel. And if I use the right type of situation here, the right type of paper in this case, my oil will go through the filter paper, and the crud stays up here in the bottom. So I'm filtering, which is like a cleanup process that we need to talk about. So that's filtration. All right, so number 5 is chromatography. We've mentioned chromatography in the last lecture module. We didn't go into detail with it. We'll go into more detail with it now. But chromatography is all about separation. That's what chromatography does. So it separates the solution components from each other. So again, alphabet soup, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. And then I only want 1 or 2 little letters maybe out of that entire alphabet soup. So chromatography is going to separate the letters from each other. I'm going to be able to focus in on only one letter, and then I'm going to be able to capture that letter and send it on through. So that is the purpose of chromatography. That's what we said chromatography was in the last lecture module. You probably did some labs in chromatography already, and it's just going to come back and we get to talk about it again. Number 6, mixing and blending. This is another unit operation that we can talk about. So mixing and blending combine solids, and 2 solids can be mixed together. That's absolutely perfectly okay. So 1 solid and 1 solid, salt and sugar maybe, and I can mix that up, and when I mix that up, that's mixing and that's blending, and I'm changing something from what it originally was. I can also take solids and I can put them in liquids. That's another option for me as well, right? That's not a big issue. I can take sugar and I can put it into some water, and that sugar will dissolve. So mixing and blending is going to have to be required. And then I can also do multiple liquids. That's not an issue either. So I can take water, and then I can take alcohol, and I can make me a mixed drink. And that alcohol and that water can come together, and I can mix it and I can blend it, and it stays as one, but changes have happened, and that product is no longer like what it was in the original step. So mixing and blending are going to be other unit operations that we can mention as well. Number 7 is evaporation. And it says evaporation changes a liquid into a vapor, usually by heating the liquid. Well, okay, this is not a big concept that I have to grasp. Evaporation, we kind of mentioned this before. If I take like a swimming pool, a little kiddie swimming pool, and I put it down into my front yard, and I take my water hose and I fill it halfway full with water, on the hot summer days, I can go back, 3, 4 days later, and that water is going to be much lower, if not completely gone. Evaporation has taken over. So evaporation is changing that liquid into more of a gas form, and it's evaporating on us, right? That's what evaporation is. So I can use evaporation as a unit operation as well in the biomanufacturing process. Number 8 is sublimation. And sublimation says it changes solids into gases without a liquid intermediate. All right, so what this means is that, let's say I go into my kitchen, and let's say I go into the freezer and I get an ice cube. Okay, great, I've got an ice cube. Ice cube is a solid form of matter. It's solid form of water. So I take that ice cube and I set it into a cup and I put it on my kitchen countertop, and what's going to happen is that that solid will actually melt, and it will melt into a liquid, and that liquid is liquid water that we are very familiar with. So this is not sciencey, but it is really. I mean, I know that you know this. I know that you can take an ice cube out of a freezer and put it into a cup and let it melt, and that melting process changes it into a liquid. But guess what? It's sciencey too. I mean, that's what science is based on. I mean, it's the same kind of situation, and that's why I always say kitchens are very much like laboratory environments and like science environments. They're really no different at all. All right, and then next up, if I go from a liquid, then I can actually heat this up a little bit, and I can then turn it into water vapor, or I can turn it into gas. So with that said, I can take the liquid and I can boil it, and that boiling process changes it into a gas form. All right, so I put water in a stovetop, I get ready to boil spaghetti noodles, I crank the heat on it, and that heat changes it into a gas vapor for me. That's the process of boiling. That is science. That really is part of biomanufacturing, maybe, depending on what we're doing and what we're working with and what we need. So sublimation, which is what started this entire discussion, sublimation is the idea that I can actually skip the liquid step. So I can take the solid out of the freezer and it goes directly to a gas form. This is sublimation. That is what that means. So that's why it says it changes a solid into a gas without a liquid intermediate. And it gives you an example, and it says dry ice. If you've ever worked with dry ice before, it is a solid block, and that solid block gets put down into a cooler. There's no liquid intermediate that forms, and that dry ice will eventually go into a gas fuming cloud, and it keeps your stuff cold, hence dry ice. So it goes straight from a solid to a gas form, and hence sublimation is there. All right. Next up, if we continue on and just kind of keep listing some of these options for us, we were at number 9. Number 9 is condensation. So it's changing the vapor back into a liquid. So the opposite of boiling. I mean, it's taking the gas that we've generated on the stovetop and it's condensing it back down into a liquid. So maybe you see some condensation up on your upper cabinets, or maybe you've got a microwave above your stovetop. You see some water residue that gets kind of stagnant or latches on to those surfaces. Well, that's condensation at play. So that's also a unit operation that we can talk about. Again, nothing new, just in a different point of reference. Number 10 is called heat transfer, and heat exchangers move heat from one fluid to another. So if I've got some fluids that are super hot, then I can send some cold solvents around it, and it can extract the heat from it and cool those things down. Again, we've kind of talked about this in previous modules. It's going to come back. We get to revisit it again. That's great because repetition's the key. Number 11, stripping and distillation. So stripping and distillation use evaporation and condensation to separate liquids in a mixture. So we're going to talk about this in a little bit more detail. I think that we have to take maybe a little bit of time to really flesh out these ideas with stripping and distillation. I don't want to rush that all the way through, so that way you get a really good grasp of what's going on here. And then finally, number 12, clean in place and steam in place. Remember, CIP and SIP. This is basically all about cleaning production equipment, and we are removing stuff. And what stuff we are removing? Well, that's chemical and organic residues. So all of this can also be unit operations that we can talk about, blah, 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 blah. And we are going to revisit some of these concepts as well. So in the next video, we're going to pick up from here and we're going to continue on. I'm going to give you kind of an example of how or in what type of situation is more than one of these processes going to be needed. And I'll relate it to something that's very familiar to you. And with that said, I'll end the video here. So come back. I know you've only watched me for 20 minutes. It's a fresh lecture module. You got nothing else to do. So go ahead and hit play on the second video and continue to watch me with Module 6 Part 2. So there's going to be many parts just like the other modules. Don't waste any time. I know you're having fun. Write down those notes. Study. You don't even need to study. You just listen to me and you'll do great on those assignments. I hope at least, as long as you pay attention. All right, so I'll see you in the next video.